right, as Thomas said, you can find me daily on the Scrum Master Toolbox podcast, where we interview software practitioners every single day of the week and sometimes even on Saturdays. We just had a very interesting series on AI-assisted coding. Our podcast is focused on practitioners, so people who are really doing it. So we've been interviewing people who are actually doing software development with AI. So check that out if you want to know more from the people who are actually doing it. And talking about software, how many of you work in what you might call a software-powered company, meaning that without software, there's no company? Great, this is for you then. Right, so we need to start with a concept. How many of you are familiar with portfolio management? Not project management, totally different thing called portfolio management. Okay, so quick intro. If your company has multiple products, then your portfolio is what products you have, develop, maintain, etc. If your company only has one product, then your portfolio is what features do you manage, develop, and maintain. So there's always a portfolio somewhere, right? If it's multiple products, then that's it. If it's only one product, then the features are then the portfolio. So we're going to talk about portfolio management because, no surprise, before you do any software development, somebody decides what software should be developed. That's a portfolio decision, right? It's not, let's do this project, yes or no. That is also a portfolio decision, but that's not what I'm talking about. What I'm talking about is what projects could we potentially do and which ones do we choose and why? Or as I like to call it, what products could we potentially develop and which ones should we develop and why? So what is the main task of portfolio management in a software-powered business? Any ideas or thoughts? Does somebody want to venture a guess of what is the task of portfolio management? Prioritizing. Very good. That's part of it, for sure. How to or when to stop doing something. Absolutely. That is definitely part of it. If we take these priorities and end of life and starting new things, investing more in ones, less in others, those are all, let's call it variations of what should we be working on, which, of course, is not the key question for portfolio management. Portfolio management needs to ask a question that goes even before that, which is, what are the right things to do? Right? What are the right things to do? In fact, one of the key questions that I ask people working with this type of decisions is, are we working on the right things? That's a very important question, because if we're working on the wrong things, doing them better is not going to help, right? Now, these right things, though, is not an easy question to answer, because there's a lot of uncertainty. I read this book quite a while back when I was preparing this talk a few years back. And if you pay attention to the subtitle, is very important. Making smarter decisions when you don't have all the facts. And that's what we need to do at portfolio level all the time. We don't have all the facts. A very simple example. If you're going to release a product, you have some hope, some wish of how it will be received in the market, right? We release a product because maybe we want to get more customers or more money from the same customers, whatever that is, right? But do you know that that will happen? Only after the fact, right? So when we make decisions, we need to learn to live with uncertainty. And this is the key task of portfolio management. So when I asked this question, it was a little bit of a leading question, because what I really want you to understand is that portfolio management's role and main task is to manage uncertainty, not products, not features. That is the output of their work. But their key work is to manage uncertainty, because we don't know if the decisions we're making are going to have the impact we hope for. And of course, you know how software works. The more you write, the more it costs. If it doesn't sell, it only costs. And that's a key uncertainty that we need to manage. Okay, so that's topic number one. Keep that in mind. Portfolio management is about managing and living with a world where we don't have certainty of outcomes. And then I'm going to undersell Jan Bosch's request. He talked about every agile team needing to produce 20 times more value than what they cost. I'm going to undersell it and say, let's just focus on 10x for now, which is not in itself a simple feat. But I want you to keep this vision in mind. Imagine that you were able to 10x, that is multiply by 10, your company's profit, revenue, or any other variable you care about through an AI and agile, let's call it based, enhanced product development process. That's our goal. By the end of this talk, you will know how to do it. That's the vision I want you to keep in mind. But of course, always accepting that there's a bunch of uncertainty we need to deal with before we can get to that vision. But before we go there, I know this is an interesting vision, it is for me at least. We do need to step into reality for a little moment. What does reality look like? Are you familiar with this? Do you know what this is called? Anyone know what this is called? Oh, there you go. Somebody knows how to read. Thank you. Yes, this is a Gantt chart. How about this? If I just quickly flip between these two slides, what is the difference? Any difference? I don't see any difference either. I mean, this is called a portfolio plan, this is called a Gantt chart, but they look very much the same, don't they? 99.5% of big projects fail one way or another, time, budget, or benefit. Dr. Bent Fluvbjerg's work also includes some specific focus on IT projects. And the results are even worse. So think about this. The average project out there fails on one of three dimensions or more 99.5% of the time. And IT is even worse. The only question I have for us as a community, what the hell are we doing using projects still? But we'll get back to that later. All right. So we have problem number one. We are managing the future because portfolio is all about the future. We are managing the future of our companies like we managed projects before 2001. Right? Remember this chart? It's exactly the same as a project Gantt chart. We need something different that focuses our companies and our decision making on outcomes and adaptability. I want you to focus on these two words, because we're not going to get 10x better if we don't focus on outcomes. But because we are living with uncertainty, adaptability is the only way that we can manage that uncertainty. But it doesn't stop there. This one, Jan Bosch already mentioned earlier today. This is a book by Ron Kohavi, Diane Tang, and Yan Shu. And they collect information from many companies that release experiments online. They talk about how to run experiments in a trustworthy way. And he says that only 10 to 30% of changes have any measurable value. 10 to 30%, which is about what Jan Bosch said this morning, right? Like most features add no value, about 10 to 30% add some value. If you have an incremental improvement expectation of 5 to 10% a year, if you now make the calculation, you know that in order to just keep the same level of revenues you had last year, you have to release a lot of stuff, if only 10 to 30% of those will have any impact. Don't forget that software depreciates very fast. We all know this. Everyone who has a mobile phone knows how quickly they lose value, right? That's because what's inside the software has no more value than the new one. And the new one is shinier and newer and probably has yet another camera. Soon we will have 20 cameras in the back of the device, right? So just to keep the 5 to 10% annual revenue increase that we need to justify our investors' expectations on our business, we need to run as fast as we can just to stay in the same place. That's the Red Queen effect, right? You run as fast as you can just to stay in the same place. And then we have this problem. Projects optimize for predictability. Most management frameworks out there optimize for predictability, not value. But if we assume that we live in a world where uncertainty is there, it's inherent to the world we live in, predictability is the opposite of what we need. What we need is adaptability, right? Because any predictive planning approach, like this one over here, this is a predictive planning approach, will fail. The question is not if it will fail, the question is when and how badly it will fail. So anything that focuses us on predictability moves us away from what we need, which is adaptability. So we want to focus on what I would call agile product management, which focuses us on the overall value of the portfolio, you know, the set of products or the set of features, and of course on the return on investment. So this takes us to problem number 2. When we try to maximize predictability, which is what most management approaches do today, we lose sight of what is the most important for our companies to survive, which is to maximize the value generated from the investment. And then there's complexity. How many of you know what this is over there? Can you say what it is?
Well, it's a complex system with it looks very simple.
Yeah.
But it's extremely complicated.
Yeah, and the complex is that we know there's a couple of attractors here, but we don't know where the system will be in the future, right? We know more or less that it will perform in those lines that you see there, but knowing where it is now does not help you know where it will be next, right? That's complexity. We only need 3 variables to have emergent complexity. 3 variables. How many variables are there in a normal company acting in a very simple market? Yeah, the answer to that question is as many as you want to see. The others you need to ignore, right? In other words, a lot more than 3 variables. But you only need 3 variables to have an emergent complex system. So the takeaway here is that in nonlinear systems, with just 3 variables, we have complex emerging behavior. And in complex emerging systems, estimation, or to make it even more obvious, any predictive planning is useless at best, but mostly it's quite bad for us because it locks us into a strategy to achieve our goals and removes adaptability, right? This is the key thing I want you to keep in mind. We live in a world that is complex by nature, and the complexity cannot be removed by analyzing it one level deeper. Well, we've tried that. Okay? It's analytical thinking. We, over time, figured out that actually that doesn't work very well. So we tried to reduce the timelines. Anyone remember when Scrum wanted to have 4-week sprints? Okay, what did we do after that? We went 3-week sprints. And what do we do after that? And what are we doing now? Still 2 weeks? Come on, guys. Isn't it obvious that the next step is to go to 1 week? But what is that? It's an attempt to manage the unpredictability of the real world by reducing the scope of where we apply analytical and predictive management, right? That's what we need to do. Okay, estimation is useless in that domain. In the real world, estimation is useless, because plans are static, but when you manage a portfolio, which has a lot more variables than any single delivery, whether it's a project or a team doing it, plans are static, portfolio management requires dynamic adaptation, this is the key part, in near real time. We'll talk more about real time later. Okay, so here are the problems. We need a method that focuses on outcomes and adaptability. This is what I call agile product management. We need an approach that tries to maximize value generated. Quite simply, it's called experimentation, or as I like to call it in banks, where I talk often, is let's work like a scientist, because they don't like experiments. And then the third, we need real-time outcome simulation. We'll talk about what that means in a second. Real-time outcome simulation to provide insights, learn new things, that lead to adaptability. I talk about an AI-powered portfolio simulation. I'll show you a mock-up of one of those in a minute. And we need that because there's no way a human can process the amount of data the market is throwing at you and then digest it and present options without first having the automated data collection and then having the automated data processing and then having the insights extraction. Okay, so the 10,000 feet solution is agile plus AI. I'll talk about what that means in practice. When I mean about agile at portfolio level, I'm talking about agile product management that focuses on value discovery. This is important. Has clear kill criteria for non-performing features or products. Very simple example of why projects are a bad idea. You don't have kill criteria in projects. Nobody would do that. It's called suicide, right? Like if I'm presenting something to execute, it's my project, and I have a kill criteria there, it's literally suicide. Suicide for the project and for my career. We have our reputation and political capital within our organizations invested in continuing a project that makes no bloody sense. The only way we can implement kill criteria is if the performance of the product or feature is decoupled from the career of the person developing the product or feature. How do you do that? You have the kill criteria for the feature or the product, not for the project. Because projects are represented by project manager and project team. But the product is a standalone entity, right? And if you think about how does evolution work? Some individuals survive, and the survival of those individuals makes the species stronger. We can do this in products. Some features survive, and the features that survive make the product stronger. We can also do this with products in general. Some products survive, and the products that survive make the company stronger. Right? So kill criteria is a critical aspect of this, and then we want to use experimentation and continuous learning. How do we do that? With AI and simulation. And I'll discuss a little bit about that. But the key idea is it takes a long time to run experiments. If I do an A/B test on an emerging product that doesn't have a lot of customers, that A/B test will maybe need to run 4 weeks, 6 weeks, sometimes even half a year before you get statistically significant data to look at the result of the A/B test. So you don't want to do A/B tests on emerging products, right? So what do you want to do? You want to simulate future performance given your understanding of what the world is like. And you want to do that in multiple different scenarios. For example, if you're launching a product where there's no competition, for sure you want to simulate what happens if when we launch there is a competition, right? So we need some way to generate these scenarios, AI, and then simulate them. And we'll talk about what that means in practice. I interviewed Rebecca on the podcast. She has this book called Survive, Reset, and Thrive. I really like the book because she's actually describing what agility feels like at a company level, right? Like at the board level, right? When she talks about survive, reset, and thrive, she mentions that successful teams don't just rely on facts. Predictive planning needs facts. They act on beliefs. And then they use belief trackers. I believe that there will be no competitor in this space for the next 6 months. But then a competitor emerges. You now need to update your belief tracker. Now you can't say, I don't believe there will be a competitor. Now you need to change the system so that you're saying what will happen when a competitor comes into the market. You need to update your beliefs. That's what she says, right? Companies that succeed, they have a set of beliefs that they act on, and when the world changes, they update the beliefs. Do you know what that is called? It's Bayesian logic, right? This is nothing new. We already have all the science, all the technology we need to do this. AI just makes it simpler. We need to start managing our companies, in this case, portfolios, just like Annie Duke talks about herself managing her poker games because she's a poker player. And what do poker players have in common with managers that are managing a portfolio? They need to act on incomplete data. They need to manage under uncertainty. So we have a lot to learn from poker players. So keep this in your short-term memory. Just like Annie Duke talks about in the book, we are talking about bets. Bets is a technical term here, right? So we're not just using this as a generic word, we're using this as a technical term. A bet is when we make a decision with an expected value and a certain likelihood. We do this because we expect this will happen, and we believe this is very likely, not likely, etc. Right? So we're updating our beliefs, just like Rebecca Humkes suggests. Okay, so problem number 1. What is the method that focuses on outcomes and adaptability? Okay, so this is a real-life case study. It's a travel agency, online travel agency company. And we did one sprint, 2 weeks. That was it. The team was bored. We're doing pixel pushing here and there. We're just working on the user stories. We want to do something different. So the product owners got together. That's one of them over there. That's Fabian practicing his sharpshooting with the Nerf guns. And Fabian and Mario got together and they said, okay, this could have an impact. We don't know if it will have an impact, but we believe it will. Right? We're expressing a belief. So they got together with a team and they designed, how will we implement this in 2 weeks? Because that's all we got. We don't have anything else. Managers gave us 2 weeks to do this. How do we get it done? They agreed on it. They started implementing. That single feature generated 420,000 extra per year in revenue. 2 weeks of effort. A lot more than what Jan Bosch said this morning the team should produce. But of course, most of the time, they didn't work like this. Can you guess how they worked most of the time? I already said it, right? They used the predictive planning method. These are the things we believe we will need. Here's a project. Spend the whole next year doing these things. When they didn't do that, this was the outcome. So we need to create short feedback loops. After 2 weeks, they started collecting usage data. A couple of days later after release, we saw the first sale from that feature. Over time, they got to 420K of yearly revenue added just from that single feature. And we need to have clear value-driven criteria. This team, with the help of Fabian and Mario, established kill criteria for every single aspect of that feature. And they actually removed code from the code base for the parts that were not working. This is a win. Not only do you now know what works and what doesn't work, but now you have less code to maintain. It's a win in all fronts. Right, so that was problem one, a method that tries to maximize, this one, a method that focuses on outcomes and adaptability, right? After 2 weeks, they immediately got the feedback. They could adapt. Outcomes, they were only focusing on that critical, in this case, conversion metric for that feature. When we look at problem two, we need an approach that tries to maximize the value generated. Now it's the key part, not maximize the work done. This is a consumer application. It was already in the market. So we already had customer base. We started tweaking the packaging. The packaging in software products is basically the pricing, how long the license is, what kind of offers you present to the users, etc. Right? That's what's called packaging in digital products. In physical products it's different, but that's what we call packaging in digital products. With a 2-week experiment, we validated a core assumption about the packaging, how to present the product to the user. That change generated a change in revenue from about 842 euros a day to 13,698 euros a day. The daily metric here is important. Why? Because when you need to learn, you can't wait a month or 2 months to get the data back. You're looking at a specific daily metric. And in the workshop that I do for product owners, we create the whole system on how you can go from this high level, maybe monthly or even yearly metric, and you decompose that into metrics you can follow every single day. This is a key feature. And if you can do that, you can manage your products only focusing on value. So with that, of course, we went to around 5 million of revenue a year, which was great because we bought that company for 2.5 million. That's actually 16 times growth. So not the 20 that Jan asked us to work on, but pretty darn close. Another aspect of this is experimenting before you have customers. Sooner or later, every portfolio will introduce new products or new features that have no adoption yet. Adoption 0. So how do you do that? So in this specific example, it's a 1.5-year project, right? This was literally a project. It was predefined what it should do in the beginning, and then it was going to market 1.5 years later. But we didn't wait 1.5 years to start collecting feedback. So we designed specific experiments to collect data while we were developing the product. We got together with the salespeople, and the salespeople helped us crystallize our assumptions into sales conversations. So we were both acquiring customers, so recruiting beta customers in our case, that's how we would phrase it. And we were getting new customers, potential adopters later on, while we were learning what worked and what didn't work for them. This product went from 0 euros in revenue to 10 million in 4 years. That was one team. I think pretty successful. The key realization here is that to find what actually grows the product, you must test many ideas. So we developed this concept of micro-experiments. Micro-experiments are things that are designed only to collect information. Nothing else. This is not about creating the next greatest feature. This is not about getting that many more customers, even if those might actually happen. This is about getting information quickly, right? We start from a question, we define the assumption, we design a micro-experiment. The key rule of thumb is a micro-experiment is something that goes from question to answer in 24 hours or less. So the key takeaway is that the goal of portfolio management is value creation, not, this is key, project execution and follow-up. Unfortunately, how many of you work in organizations where there's something called PMO, or Project Management Office? Unfortunately, PMOs, who typically own portfolios of projects, don't care about that at all. They only care about execution and follow-up. They are never rewarded, focused, or asked to care about the value that their projects produce. So is it any surprise that they often produce no value? But they're on time. Well, at least 0.5% of them. That's the data. Okay, and now problem 3. How do we get to real-time or near real-time outcome simulation? Because here's the thing, at portfolio level, you're so far from the market that if you want to wait for market feedback before you make decisions, you're going to be waiting a long time. And in a world where uncertainty is, it's the reality, and where in a portfolio management approach that accepts that we need to manage under uncertainty, that kind of delayed feedback is death. So we need to get to near real-time outcome simulation to prove that provide insights that lead to adaptability. Because adaptability is not a process you take in. Adaptability is a reaction to new information. The process can shepherd, orient the reaction and the information collection. But that is what adaptability is, right? It's about reacting to information that is coming in. So a long time ago, I wrote this book. It's the No Estimates book. And one of the things that I learned is that when I was developing the ideas for, even before the book, for what I was doing at the time, one of the things that I learned is that people don't react to data. Sometimes because they don't have the data, and sometimes, and this is what is really painful to admit, they have the data, but it doesn't fit their world model. I remember talking to a Nokia project manager. I had been collecting data. I told this program manager, actually, 6 months into a 12-month program, I told him, look, I've got the data. It shows that we're going to be at least 6 months late. We should do something about it. And the program managers at Nokia had a very special superpower. Some of you might call it email. They can email everybody in the program and get an answer quickly. So that's what he did. He emailed everybody in the program, the project managers, obviously, who know all of this, and asked, will you release on time? Guess what was the percentage of people that said yes? Any guesses? 100%. It's the only right answer. When you get asked, will you deliver on time? You can't say no, right? Well, statistically, there's a 0.5% chance you're right if you say yes. But still, you can't say, no, we will not deliver on time. So everybody said we will deliver on time. 18 months into a 12-month project, the project got canceled, the program got canceled. I gave this information to the person had the information, they refused to accept it, and they preferred to accept opinions from people whose job depended on giving him the answer he wanted. We're not very good at dealing with data. So that's a danger that I am aware we need to face. But what I'm trying to, at portfolio level, what I'm trying to suggest here is that we should focus on simulating the results of our bets over time and use real-time information from experiments and other sources to inform our belief in those bets. Has anyone here bet on sports? I do. I have no problems admitting that it's actually quite entertaining, although sometimes painful. All right. So when let's say you're betting on a football match. You bet before the match starts. There's a certain likelihood that the team you bet on will win, so you get a return based on that likelihood. But if the other team scores, you just lost money. Because if you had bet after the other team scores, the likelihood of you winning would be lower, so you would get a higher return. So the bets are being updated in real time. If you ever bet on football as an example, and you can do this with fake money. There are many sites out there that allow you to test it with fake money. You lose no money, but you gain the experience. It's very informative because that's real living with uncertainty, right? There's new information coming in, it updates the odds, it changes the return. And the cool thing is that these days they even allow you to close your bets before the game is out. So for example, if you bet that your team is winning, and your team is actually winning, and the game is not over yet, you can close the bet, get the money, and not worry about the result. Or wait until the end and make more money, or eventually lose it all. That's what living with uncertainty really is. So actually playing with these things is very informative. So we need to build this system. Imagine that your portfolio of products or features would be in that website. And that website would be giving you near real-time odds, probabilities of those features and products being delivered on time and having the impact that you want in the end, right? That's what we are trying to create here because we already know that estimation doesn't work in a world where uncertainty is present. Because for estimations to be valid, you need to have removed the uncertainty. So what we are trying to do now is to actually build the idea of foresight into our planning processes, right? So I talked about predictive planning. Predictive planning is when we say, we do these things and then these things happen. We predict that. And then we organize the work based on that. When we talk about foresight, it's different. Foresight is, what are all the possible things that could happen if we do this? Right? We are trying to generate insights into the future. That's called foresight, right? Seeing the future, but we don't actually see the future. We see several possible futures. And that informs our decision today. So that's what we want to do. In one case, this is an example from a, oops, wrong slide. This is an example from a financial institution. They did data evaluation on their own product, and then they evaluated the other competitors' products, and then they simulated outcomes. They found a gap. And that gap was where they developed the new features, because they understood that their performance was below what the market could already take in that specific aspect of the product. This is called foresight, right? This is not predictive, although it is making a bet about the future. This is about simulating the future and making decisions based on that. So how do we bring this all together? We already know how to build resilience. And it doesn't look or feel like project management. In fact, if you look at this work by Nassim Taleb, Anti-Fragile, he talks about understanding the world as uncertain and your actions as a series of bets that get informed by the information that you collect over time. But he also talks about something that is very interesting, which he calls the barbell strategy, which is that you simultaneously place two bets on opposite ends of the spectrum. So you have a payoff curve that looks like this. So if the world moves this way, you make a lot of money. If the world moves this way, you make a lot of money. If it stays the same, you may make some money or no money at all. Right? This is called the barbell strategy. And this is what he defines resilience. Resilience is when you are able to incorporate, adapt to adversarial outcomes. So something goes wrong, and that helps or doesn't help you, but doesn't harm you. He also talks about anti-fragile, which is what evolution is all about, which actually makes you stronger, right? Like we all heard this phrase, what doesn't kill you makes you stronger. I'm from Finland, we do sauna, so we know exactly what that is, right? What doesn't kill you makes you stronger. So that's the idea. We already know how to do this. There's already the mathematical models in place for us to be able to do this. No surprise, Nicholas Taleb used to be an investor. And I mean like a person who put money on stock markets, bond markets, options markets, futures markets, whatever. Real money that he was putting his own money. Of course, he also worked as a trader, but then later on with his own money. And he made money with that. So he was actually working in an environment where betting is everything you do. Right? So he developed his theory based on that aspect. All we do is bet, just like poker players. which is the next aspect. If we frame decisions as bets, we are already getting ready to adapt when the beliefs change over time. And this is very important. All her work is about making decisions under uncertainty, and it's definitely a great read, although I would recommend, if you ever look at it, read the first 4 or 5 chapters. The rest you can skip, but that's where the core of the argument is. And how do you avoid ruin? Because here's the biggest problem we have with bets. Bets don't always have a positive or neutral outcome. They may have a negative outcome. So how do you make decisions under uncertainty when there is the risk of ruin? Guess what? We also have a solution for that. It's called the Kelly criterion. There's a lot of work done on this. There's a mathematical sound system behind, and it helps with decisions such as, okay, investment A has a 60% chance of doubling, but also 40% chance of losing it. Investment B is a little bit more conservative. We have a 75% chance of 10% gain, 25% chance of a 10% loss. The Kelly criterion helps you to define how much you should invest into each of these, controlling for and avoiding the risk of ruin. This is important, because if we're going to make investments, the one thing you don't want as an outcome is death or bankruptcy in the case of a company, right? So we already have all of the framework for this. So the only thing we're really missing is building that feedback cycle. And that's what we call agile portfolio. So here's how AI can help us. That's a simulation dashboard for a bank. And it tries to solve this problem. First, traditional product experimentation is very slow. So if you want to learn faster than what normal traditional product experimentation gives you, you need simulation. Simulation needs to be built on a solid foundation of knowledge and beliefs. So we use Bayesian logic. AI can help you frame your Bayesian beliefs. It can help you set up the whole system, and it can even give you insights. With the help of simulation, we now don't need to consider only 1 or 2 scenarios. You can consider 500,000 scenarios. Because here's the thing. If there's 3 variables with 5 states each, you already have 15 possible states. Okay, so how do we do this? Humans are not very good at this. Imagine the spreadsheets for that. And now put 10 or 20 variables with 500 possible values for those variables, and it's out of control. Computers are really good at that. You know, like from the Matrix, never send a human to do a machine's job. Machines are really good at simulation. And now with AI, it even helps you build the simulation. So with AI and Bayesian simulation, we finally can do rapid hypothesis testing and value discovery, which helps us to expand the amount of insights we can collect. Just to give you an idea, when you do an A/B test, you put the A/B test out. Let's say, for the sake of arguments, that it's an ABCD test. So you're evaluating 4 possible options, one of them being doing nothing, obviously, and then another 3 options. With simulation, you can now have, in minutes, what are the 3 most likely other options to test. When you do ABCD test without having a simulation step before, you have to guess what is ABC from those 4 options. Now, you might say, yeah, but just create the options. Well, have you ever sat in a meeting where there's 5 different opinions on what we should be testing? It's not going to be a quick meeting. Also, it's probably not going to help the team dynamics and morale of the team when you can't come to an agreement. So with a system like this, instead of saying, oh, we'll test these 3 options plus the do nothing option, we can say, hey, let's run these 500 different tests. And based on the data we have and the beliefs we hold from the world, figure out which of these 500 are the most likely to succeed against the current state. Because when you do an A/B test, your B version is there to be better than the A version, right? So you need to choose an A that has a likelihood of being better than the B. Without data, without simulation, it's only guesswork. What do we usually do when we need to guess? We do something like this. So the goal of the simulation is not to tell you what's better. The goal of the simulation is to try out multiple possible scenarios, and based on your current available data and beliefs, tell you which of those scenarios are more likely to have the impact that you want. That's it. It's just like going to a sports betting website and looking at the odds. If a team has a higher odd of winning the match, most likely it will win the match. If it's very close, you know, it's not sure. If it's very different, you know, you bet on the underdog because there's a huge return, right? So data is important because of that. It helps you weed through the whatever number of options you might consider and focus on those that have the most likely positive impact. Okay, now one of the things that I often hear when I talk about this is, will it work for my product? The fact is that what we are talking about is nothing new. It's just new applied to product management and portfolio management. What we are trying to implement with this approach is adaptability and value focus instead of predictability and maximizing the work done, which is what the techniques we use today gives us. And somebody might say, well, but 10x growth is unrealistic. Well, I mean, I just gave you 3 examples where 10x was kind of a low level of expectation. We can get a lot more. And by the way, anyone working with software, if you don't expect a 10x return, don't even start working on it. Software is not a good medium for small incremental improvements. It's very expensive, it takes a long time to deliver, it's very error prone. Software is debt, it is liability. Software is not value. If you can deliver the same value without software, don't touch the software. And by the way, if you aim to have 10x return and you fail, you might only get 2x, you still get promoted anyway. More code really isn't the solution. Over 25% of Google's code is now written by AI. This was from exactly 1 year ago. If you ask this guy today, it's probably like 90%. And that percentage will only grow. More code isn't the solution. You can't be more successful by writing more code. In fact, I would suggest otherwise. You're more likely to fail if you write more code. So the question is, who will take advantage of this? This works. And by the way, if it doesn't work, it still gets you to focus more on value. It still gets you to be more adaptable and takes you away from the predictive 0.5% chance of success approaches like project management. So the key question for you is, are you ready to give this a try? Because, you know, 5 to 10% revenue growth or product performance growth is okay for the next 6 to 12 months, but with AI coming in, it's unlikely to be more than that. So if you talk to me right after this session, we can talk about having a workshop on how to build this in your context. And now we have some time for questions.
Yeah, I still wonder about how you get the data into the simulation and you verify that the simulation is anything close to reality.
You don't need to. The goal of the simulation is not to be close to reality. The goal of the simulation is to allow you to explore multiple possible scenarios without waiting 5, 6 months, or even 5 to 6 years. The scenarios will give you insights. That information will inform your decisions. I'll just give you a very simple example. Let's say that the only variable that we care about for the sake of this example is, will there be another competitor offering the same or similar product in the next 6 months? These days, strategists do this. They consistently ask questions like this. What do? They build models, financial models typically, where they have number of users, adoption rates, et cetera, and then they do this in a spreadsheet. Typically, there's 2, maybe 3 scenarios, right? Like no impact, high positive impact, high negative impact. That's typically what they do. But that is based on very biased, unverified information, which can never be updated later on. The strategists, once they've done the model, they've shown it to the board, they go home, they work on other models. A simulation process can take that model and now update that model every single day based on market information. A very simple market information, is there a competitor entering the market in the next 3 to 6 months? Because the model makes no sense if there is no competitor, right? Because the model evaluates the impact of having a competitor in the market. This is one example. I'll give you 4 or 5 different variables. How close are we to releasing on the time that we expect? How close are we to closing certain contracts with certain customers? How close are we to hiring the people we need to execute on this strategy? How likely is it that the US will generate a new batch of tariffs that will affect our product sales? All of those are variables that will never be considered by strategists that did a model 6 months ago. The model will never be updated. The model is useful. It is so useful, we should automate it and get it updated every single day. At portfolio level, this is critical because we should be making decisions at portfolio level not once a year, not once every half year, not even once a quarter. We should be informing these decisions every single day. This is why the title of the talk is called Think Like an Investor, Not an Accountant. Strategists who do these models, they do accounting, right? They do it once, they publish the model, give it to the board makes a decision, done. What investors do is the opposite. They update their investment portfolio every single day. How do they do it? They collect information from the market, they see the performance of their stocks or investments, whatever those might be, and then they make decisions every single day. Software is no different. We are in business as well. And the fact that we're thinking like accountants, doing 1-year plans, keeping the plan, executing the plan, even when all information tells you it's the wrong plan to execute on, is not how we are going to generate value. So the simulation is about bringing to portfolio management strategies and approaches that investors have been using for decades. And if it works for them, they work with uncertainty every single day. Why wouldn't it work for us?
Thank you very much, Vasco.
Thank you,
Excellent.
everybody.
Thank you.